Why did the mathematician like decimals? Because without them, numbers had no point. Okay, let's go. So we're going to look at what are called the four operations of decimals, that is adding, subtracting, multiplying and dividing. And we'll start with what should hopefully be the easiest one. For adding and subtracting decimals, we want to put the numbers on top of each other and make sure we line up the decimal points. That's kind of the key thing. If you don't do that, you're going to have a bad time. Second thing, we want to fill in any gaps with zeros and then add or subtract them as we would with normal whole numbers. And then we're going to keep that decimal point in the same place. So let's do a couple examples of this. For the first one, we've got an addition. We've got 6.132 plus 4.32. So let's set them up on top of each other. 6.132 and 4.32 so that we have lined up the decimal points. Second step, fill in any gaps with zeros. Now you don't have to do this in a second colour, but I'm going to, just to illustrate that I've done that. When I say gaps, I obviously mean on the decimal sides of things. We want them to be the same size because then they are easy to add together. Then add them together as with whole numbers. So 2 plus 0 is 2. 3 plus 2 is 5. 1 plus 3 is 4. 6 plus 4 is 10, so carry the 1, but that's just going to be 10. And keep the decimal point in the same place, 10.452. Job's done. What about a subtraction here? So we've got 9, take away 0.245. Now where's the decimal point with 9? It's kind of just after the whole numbers, so it's 9 point something. And then we've got 0.245. Okay, that's step 1. Should probably put some minus signs on here. We then want to fill in the gaps with zeros, so let's do that. And we've got 3 zeros that need filling in. And here's where you've got to be careful with essentially borrowing. We need to do 0 take away 5 here. That can't be done. So we'd want to borrow from the next 0 along. But also, that can't be done because there's nothing to borrow from. So we look at the next 0 along, and there's nothing to borrow from there either. So we're actually going to have to borrow from the 9. So we'll cross that out, put in an 8, and we'll carry a 10 along. We'll cross that out, we'll put in a 9, and we'll carry a 10 along. We'll cross that out, we'll put in a 9, and we'll carry a 10 along. So we have to borrow from the left. Then it's just doing a subtraction. So we've got 10 take away 5 is 5, 9 take away 4 is 5, 9 take away 2 is 7, 8 take away 0 is 8, and step 3, keep the decimal point in the same place, 8.755. Okay, and then we've got this last one. Now I saw a question like this on the GCSE quite recently, and what tended to throw people off is that they like doing things in order. So they wanted to take the 3.27 and then take away the 0.294 and then add the 0.8. But you can actually rearrange things like this. So we can take this minus 2.94, we can take this plus 0.8, and we can put them in the opposite order. So I would want to add my numbers together first and then do my subtraction. So let's say that I'm going to do my addition. 3.27 plus 0.8, set it up, fill in the gaps, then add them together. 7 plus 0 is 7, 2 plus 8 is 10, so carry the 1, 3 plus 0 plus 1 is 4, 4.07, and then I'll take that number and I'll subtract 0.294 from it. Fill in the 0. 0 take away 4 we can't do, so we are going to borrow. 10 take away 4 is 6. 6 take away 9 we can't do, so we're going to have to borrow. But we can't borrow from 0, so we're going to have to borrow from 4. So that goes down to 3, that puts us up to 10. Goes down to 9, puts us up to 16. And then we're going to have 16 take away 9 is 7. 9 take away 2 is 7. 3 take away 0 is 3. 3.776 as our final answer. The other thing people will get wrong with that is they'll try and do it all in one go, like all on top of each other. Try and do your additions and your subtractions separately. Okay, so that's adding and subtracting. So multiplying then. I do want to emphasize that the method I'm going to use here is very much a short and cheap way of doing decimal multiplication. There are more thorough and long-handed ways, but this works just fine. Gets you to an answer, you just got to be good at counting. So step 1, we're going to count how many decimal places are in the question. we're going to remove the decimal point at that stage and multiply as if they were just whole numbers. Then we're going to put the decimal point back in so that the answer has the same number of decimal places as we counted in step 1. In other words, the answer needs the same number of decimal places as the question did. So here's our 3 examples. The first one we got, 0.5 times 0.09. Count the decimal places, step 1. So 1, 2, 3. This has 3 decimal places. Step 2, remove the decimal point and multiply as with whole numbers. So that would just give us 5 times 9. And that's just going to give us 45. Step 3, put the decimal point back so that your answer has the same number of decimal places as the question did. So we want this to have 3 decimal places. So that means the end of our number is going to have to be 45. Now if we made this 0.45, that would only have 2 decimal places. So we can't do that. We need to make it a little bit longer. We're going to go to 0.045. And then there, that will do it. 1, 2, 3 decimal places. 5 times 9 is 45. All done. Right, the next one, 1.3 times 1.5. Count our decimal places. We have 2 of them. Then we want to do 13 times 15. Now I'm going to use a column multiplication. Some of you can probably do this in your head, but I do want to show different methods of multiplying. So we go 5 times 3 is 15. 5 times 1 is 5. Add the 1 is 6. And then we want to use the 1 times that. So we need to put a 0 in because we're using the tens now. 1 times 3 is 3. 1 times 1 is 1. Put them together. We'll get 195. So 13 times 15 is 195. And then we want our answer to have 2 decimal places this time. So if you write 1.95, count in from the right hand side. 1, 2, decimal place looks like it's going to go there. 1.95, done. About the third one, well, if you've got 3 numbers being multiplied together, it still works fine if you've got 4 or 6 or whatever. Count our decimal places. 1, 2, 3, 4, 5 decimal places in this question, so our answer is going to have 5 as well. And the sum that we need to do is 25 times 31 times 4. Now, if that's me, I'm going to reorder it a little bit. I'm going to put these 2 next to each other. I'm going to say I actually want to do 31 times 25 times 4, because I know 25 times 4 is just 100. 31 times 100 is 3,100. And so we're done. Now you could have worked that out using a column. You could have done 25 times 31, got an answer, and then times that by 4. But if you can spot those sort of shortcuts with multiplying, it's really good to use them. So anyway, we've got our answer, 3,100. We want 5 decimal places. So 1, 2, 3, 4. We've only got 4, so we're going to have to add in another one. And this will give us our final answer as 0.03100. Now, you might want to then rewrite that as 0.031, but you won't lose marks for what we've got there. So that's multiplying, which leaves everybody's favourite, division. So for dividing, again, this is a short, cheap method that works really well. So I just want to talk through a few examples. The first step, and it's the important one, is we're going to multiply or divide sometimes both parts of the question by the same amount. I put that in bold. You want to underline that. Don't think I'll do 1 by 10 and 1 by 100. It has to be the same. So that we're dividing by the smallest possible whole number. We're going to then do the division using your favourite method, but I'm going to use the bus stop today because I think that's the best one. And that's it. Don't move the decimal place after that. Don't think you then have to undo what you did in step 1. And the problem here is obviously people will get multiplication and division confused. Multiplying at the end, you put a decimal place in. Dividing at the end, you don't do anything. I'm going to do 4 examples this time because they're 4 different, I suppose, cases to consider. First thing, we've got 17.4 divided by 3. So look at step 1. Are we dividing by the smallest possible whole number? 3. Yeah, so if we times that by 10, we get 30. That's not going to be any better. So we don't need to do any step 1 here. Step 1's already sorted. Step 2, do the division using your favourite method. So bus stop every time for me. 3, 17.4, and then we just need to work out. So 3 goes into 1, doesn't go. 3 goes into 17, got to carry the 1, sorry. 17 goes 5 times, remainder 2. 3 goes into 24, 8 times, no remainder. And decimal place needs to stay where it is. So our answer is 5.8. Fair enough. What about this second one? Well, here we are not dividing by a whole number. We're dividing by 0.02. And what I'd like to do, therefore, is divide by 2. How do I get from there to there? Well, I'm having to move the decimal place 2 positions. So that means I'm timesing by 100. But I've got to times both sides by the same amount. So this needs to get times by 100 as well, which will go to 80. Move the decimal place once, twice. So we've changed the sum from being 0.8 divided by 0.02 to just 80 divided by 2. Now we could use a bus stop method for that, but I feel fairly confident in saying the answer is 40. And step 3, that's it. Don't move the decimal place. This doesn't become like 0.40 or anything. It's 40. That's the answer. What about this third one? 3.8 divided by 500. Well, I want to divide by 5. How do I get there? I'm actually going to have to divide this time. Divide by 100. And because I've done it to one side, I need to do it to the other side as well. That'll move the decimal place 2 spots. So it went from between the 3 and the 8, went once, twice, 0.038. Remember, when you divide, you're obviously going to get a smaller answer if you divide by 100. Then, use our favourite method. 5 doesn't go into 0. Decimal point doesn't move. 5 doesn't go into 0. No remainder. 5 doesn't go into 3. 3 remainder. 5 goes into 38. So 7 times 5 is 35. So it goes in 7 times. And there's a remainder 3. So we carry the remainder over. If you end up with this situation where you're sort of carrying on past the end of the number, just shove in some zeros. It works fine. 5 goes into 30 6 times exactly. So there's our final answer on the top, 0.0076. And then the very last one, 5.12 divided by 1.6. I want to divide by, again, the smallest possible whole number would be 16. It's not a single number, it's not a single digit, but should still work out fine. To do that, we're only going to have to times by 10. So that'll give us 51.2 if we move that decimal spot 1 place, divided by 16. So, bus stop, 51.2, and I want to put 16 into it. Now, you might not be good at your 16 times tables, so in that instance, you'd write down some 16s. So, 1 16 is 16, then we'll add 16 to that, 32, then we'll add 16 to that, 48, then we'll add 16 to that, 64, 80, 5 of them should hopefully be enough. So let's go through. We'll go 16 into 5, that doesn't go. So carry a remainder of 5 across. 16 into 51, here it is. That goes in 1, 2, 3 times to get to 48. And then there's a remainder of 3 to get from 48 up to 51. 16 into 32, there it is, goes in exactly 2 times. And our decimal point doesn't move. And that's it. Our answer is 3.2. So there's the 4 operations. That's what you should need to know about them. Some lovely little cheat methods towards the end there. And that's it.